All right, guys, let's have a look at this question here. So it says, sketch the graphs of the functions f of x equals to x minus 1 and g of x equals to 1 minus x, 3 plus x, showing the x-intercepts. Okay, so in order to find our x-intercepts, we first need to let y equals to 0. So x-intercept, let y equals to 0. And so x minus 1 equals to 0, we get x equals to 1. So there is an x-intercept there at 1. Let's go ahead and find the y-intercept, just because it's important to have as accurate of a graph as possible in these cases, because as we can see, there's a part B that relies on having an accurate graph in order to solve that inequality. So let's make these graphs as accurate as possible. So our y-intercept, we've got to let x equals to 0. And so we get a y-intercept of minus 1, which is here. And so now based on that, we can tell that our line is going to look like so. So let's mark this. Whoops. Let's mark this as f of x. Equals to x minus 1. Let's go ahead and choose a different color now for our second graph, g of x. Okay, so that's g of x right there. Let's go ahead and find our y-intercept by letting x equals to 0. So we get 1 minus 0, 3 plus 0. So we get 1 times 3, and so our y-intercept equals to 3. That's that there. Okay. Now let's go ahead and find our x-intercepts. In order to do that, we let y equals to 0. So that is 1 minus x, 3 plus x equals to 0. And so we get 1 minus x equals to 0, or 3 plus x equals to 0. And so we get x equals to 1, or x equals to minus 3. And so minus 3 is going to be here, and 1 is going to be here. Now, as we can see, when you expand this out, what you get is a parabola. You've got an x squared as a leading term. In this case, it's going to be minus x squared. So it's going to be an upside down parabola, so a sad face parabola or a concaving down parabola. That's what we call it, concaving down parabola. And if we were to just join up those dots, you're going to have a very skewed looking parabola. So that tells me that the turning point is happening around here somewhere. We want to be exact because we've got part B of this question that relies heavily on exact and precise values. So let's go ahead, bring this here and expand it out so we can go ahead and find the specific point of the vertex of this parabola. So g of x equals to 1 minus x, 3 plus x. So when we expand that out, we get 3 minus 3x plus x minus x squared, which is minus x squared minus 2x plus 3. And I rewrote it this way on purpose. You have to have your x squared term first, your x term second, and your constant, which is your number, third, because the terms, coefficients of those terms will be a, b, and c respectively. And in order to find the axis of symmetry, which is your x value for your turning point, the rule is that we say minus b over 2a. And so we put the minus there. Now, again, be careful because b itself is that whole number there, minus 2. So use your brackets very carefully. Don't confuse this minus with that minus. Both need to be present, as you can see. All over 2a, where a is the number in front of the x squared. And so that's minus 1. And so that gives us an axis of symmetry, or an x value for our vertex point, as being 2 over minus 2, which is minus 1. So we can tell that our axis of symmetry of our parabola is occurring at minus 1. Now we need to go ahead and find the y value at that point in order to conclude what the specific coordinates of that vertex is. And so we take this x value and we plug it back into the original equation to find the y value at that point. So let's do this. Let's rub this out. We don't need that anymore. Let's bring that down here. So when x equals to minus 1, g of x, which is another way of saying y, equals to 1 minus, again, there's a minus there, but the value of x is also a minus, so be very careful and use your brackets. 3 plus x, which is minus 1, use our brackets. And so therefore that gives us 1 plus 1, which is 2, and then 3 plus minus 1 is 2, that equals to 4. So therefore your vertex is occurring at minus 1 comma 4, which is here. And so now, since we know that our curve is going to be symmetrical, we know that this 3 as the y value needs to be mirrored here. Okay, we can see that these 2 points mirror each other, these 2 points. But now we just need to make sure what that final point is, because you've still got a possible point of intersection going on here, which will be necessary for our solutions in part B. So let's go ahead and plug in x equals to minus 4 into our equation in order to find out what that y value is and whether there is an intersection point between these two graphs or not. It will also enable us to find out what the mirror point is on this side, so we can continue this graph as accurately as possible. So g of minus 4 equals to 1 minus minus 4, 3 plus minus 4, which equals to 5, and then 3 minus 4 is minus 1, so that is going to be minus 5. So -1, -2, -3, -4, -5. And you have an intersection point right there at -4, -5. And so that point is going to be mirrored on this side here. So now that we know that, we can go ahead and join up the points of our curve very carefully. And that way we would have answered part A and are well and truly able to answer part B as accurately as possible. So let's see what part B is asking. It says, hence or otherwise solve the inequality x minus 1 is less than 1 minus x, 3 plus x. Let's see what's going on here. Let's just concentrate on this for a second. I can see that the x minus 1 was f of x. Here's the less than. And this 1 minus x, 3 plus x was g of x. So in other words, where, or for which x values, is f of x, which is our line, black line over there, where is that black line less than g of x, which is our blue parabola? Where does it lie under? Where is our line under our parabola? And we can see that that occurs in this particular region here. Beyond those points, f of x is actually greater than g of x because the f of x is higher than the g of x on this side and on this side. And so our solution is going to be this area that is bound in between. So what are those corresponding x values? So the first one is -4. So in other words, between let's think about how to say this for a second. The area bound between x equals to -4 and 1. Now, because this is a less than, that means it doesn't actually include these particular points here. They will be like open circles in those points if we were required to solve this graphically. So we have to account for that x can be in between -4 and 1 without including the -4 and the 1. How do we write that? We say x is in between 1 and -4. And that is your solution to part B. All in all, for part A and part B, all of that working out and the graphing and all of those small details that we've paid attention to and included in our working out and in our graphs, that would give you the total 4 marks for this question.